Before we start, please make sure to subscribe to our channel to get more videos like this one. For more related video, especially a preparation like this one, check the description box below. Now let's start.
Almost every surface on the airplane is designed to serve an aerodynamic purpose. In this section we are going to discuss primary flight control surfaces. These surfaces are those that are considered required for safe and controlled flight. Primary flight controls include the ailerons, elevators, rudders, or various combinations thereof. Ailerons of an aircraft. An aileron, figure 12, is a movable control surface. They are found in pairs located in or attached to the outer wing's trailing edge on both sides of the aircraft. Their primary purpose is to control the aircraft around the longitudinal axis, or roll, by creating unequal or opposing lifting forces on opposite wings. Elevators of an aircraft. Attached to the horizontal stabilizer, the elevator, figure 12, may be one piece or two. If two pieces, they are located on either side of the centerline of the aircraft. Elevators operate together, both going up or down at the same time, and are used to control the pitch of the aircraft around the lateral axis. Rudder of an aircraft. The rudder, figure 12, is an upright control surface used to control the aircraft about the vertical axis. It is hinged to the trailing edge of the vertical stabilizer and is deflected left and right to induce yaw. Ailerons of an aircraft. Ailerons, figure 13, are often found on flying wing and delta wing aircraft. They combine the function of the elevators and the ailerons into one control. They act independently for roll and together to control pitch. Ailerons can be found on the B-2 bomber. Ruddervators of an aircraft. Ruddervators are a V, figure 14, or butterfly tail that replaces the standard tail configuration with two surfaces set at an angle to the horizontal. These surfaces control pitch by working together and yaw by working asymmetrically. The F-117A and the refueling boom on the KC-135 are examples of this configuration. Stabilators of an aircraft. As aircraft capability and speed increase, especially up to and beyond the speed of sound, a wider range of control is required than can be obtained with simpler types of controls. With the advent of the stabilator, the entire horizontal stabilizer is built in one piece and is pivoted for pitch control. Examples include the Century series fighters like the F-100 and F-105, the F-4 and the T-38. The stabilator set the stage for the high-performance fighters we have in the current AF inventory. Differential stabilizers of an aircraft are used on high-speed aircraft such as the F-15, F-16, and B-1, see figures 15 and 16. A differential stabilizer acts as a stabilator to control the pitch of the aircraft. However, each side is also able to move independently of the other. This allows the stabs to assist ailerons with roll control. This is significant at high speeds where it provides flight control functions normally handled by the controls on the wings, and allows us to further combine flight controls on the wings for weight reduction, see flaperons below. Trimming stabilizer of an aircraft. With elevators. Figure 17. Also known as variable incidence stabilizers, these controls are used on aircraft that need a wider range of control forces for different flight conditions. In such cases, the horizontal stabilizer is built to allow changes in the angle of incidence for the entire horizontal stabilizer while maintaining integrated conventional elevators. Canards of an aircraft. A canard is a horizontal stabilizer mounted forward of the wing instead of aft. See figure 18. At high angles of attack, the canard creates high-energy vortices that wash over the wing, delaying boundary layer separation, hence stall. Flaperons. The F-16 and the new Joint Strike Fighter use these controls. The flaperon is a combination of the flap and aileron. See Figure 19. Flaps are secondary flight controls and are described below. Flaperons can be operated individually or separately, and they control movement about the longitudinal axis. Secondary flight control surfaces. Secondary flight controls assist primary flight controls and give the pilot additional control capabilities. They include spoilers, speed brakes, flaps, slats, slots, and tabs. Spoilers. Spoilers are located on the upper surface of the wing. Their purpose is to decrease, or spoil, lift on that wing. Spoilers are considered secondary flight controls, although they typically work in unison with ailerons. The only exception is on the B-52. They are used in place of the ailerons, thus acting as a primary flight control surface. They are also used after landing to offset any lift that remains after touchdown so that the full weight of the aircraft is resting on the tires. This increases friction on the tires, thereby increasing braking effectiveness. Speed brakes. Speed brakes, Figure 20, can be located anywhere on the aircraft, and they operate much like spoilers. Their sole purpose is to extend into the airstream to create extra drag and slow the aircraft. Wing flaps of an aircraft. Flaps, Figure 21, are the flat or curved surfaces that extend from the leading or trailing edge of the wing. Flaps are used to reduce the minimum landing speed. They do this by increasing camber and wing area, which lowers the velocity required to keep the aircraft aloft. Flaps also increase drag, allowing a steeper descent into small fields. There are many types of trailing edge flaps. Some simply pivot down from the underside of the wing, only increasing camber, while others extend backward and downward, increasing the area as well. Some of these are slotted to reduce BLS, like slots or slats. Leading edge flaps are used to augment the action of the trailing edge flaps. Slats of an aircraft. A slat, Figure 22, is a small movable airfoil fitted to the leading edge of the wing. At high AOA, they deploy and then are ahead of the wing's leading edge. The AOA of the slat will be slightly less than that of the main airfoil. Smooth, laminar air will then flow around the slat and smooth the turbulence, which begins forming on the wings. Slats then delay BLS on the wing and delay stall to a greater AOA. Slats are often located near the wing tips to help improve overall lateral stability. A slat will also increases the wing's camber and surface area to some extent. Slots of an aircraft. A slot, Figure 22, is a fixed opening a short distance from the wing's leading edge. At high angles of attack, they serve to guide air over the upper surface of the wing. Slots serve to smooth turbulence on the wing and delay BLS at high AOA in much the same manner as slats. However, the fixed slot comes with a penalty of increased drag at higher speeds. Tabs of an aircraft. These secondary controls make the aircraft easier to fly by reducing the amount of force required to move the primary controls and to hold them in position. Tabs are also used to help correct any imbalance in the aircraft. These tabs are small controls attached to the trailing edge of the primary controls. They are moved by an electric motor and move in the opposite direction of their associated control surface. Tabs then utilize aerodynamic forces to reduce the amount of mechanical force needed to move the primary control surface.
Check the description box for more videos. Please make sure to subscribe to our channel so you can get more videos like this one. You can also ask, in the comment, for the full PDF version of videos to help you to prepare and to accomplish successfully your next assessment test. Thank you and see you next time.